In this video, I'm going to talk about using permutations and simple math using permutations. Now, a permutation is when you have a list of different values or of desired outcomes that where two things can happen. We can have the repetition is allowed, or when the values are not required to be repeated or are not allowed to be repeated. Now, there's some simple examples that we can use that we can look at permutations. And what I'm going to do is over the next few minutes, just concentrate on the most simple, where we have a permutation where repetition is allowed. Now, an example of that usually used in many cases in math classes is the use of a combination lock, where you may have a lock that's got a dial on it that's got, between 0 and 9. The second dial has, 0 and 9, and the third between 0 and 9. So the combination could be 1, 2, 3, 8, 7, 2, 5, 3, 7, or what have you. You get the picture. Now, that's a permutation where repetition is allowed. Now, what makes it a permutation is the order is important there. Like, for example, if I have a combination that unlocks the lock of 1, 2, 3, it's different than if the combination was 3, 2, 1. Yes, there's still a 1, there's still a 2, and there's still a 3, but the order of those numbers is important. So when we have that order being important, we have the permutation. And in the case that I'm bringing up with the numbers, we have a permutation where repetition is allowed. Like, for example, if the first dial is a 3, the second dial can be a 3, and the third dial can be a 3. So we have a situation here when you have a simple lock with 3 different sets of numbers on it, each between 0 and 9. We have a permutation where the repetition is allowed. Now, this is a very simple formula to figure, and this is one of the ones I'd like to start with, because as we get through, some deeper lectures and some deeper studies on permutations and combinations, it gets a little trickier. Dealing with permutations and then later with combinations is one of those mathematical operations where it starts simple and it never really gets incredibly hard, but it kind of gets tricky. The more you get into it, the more you realize it's like, hey, there's a little bit more to this than meets the eye, and a lot of care has to be taken to ensure that you're kind of applying the right formula. So a permutation with repetition is allowed is usually the easiest place to start, and that's what we're going to start here. So in the example I have here on the overhead is we're going to go over a permutation with repetition. So with that example that I gave you, where we have 3 different dials on a lock, we'll represent that as n. So we have n is multiplied by 3 times. So the first value can be between 0 and 9. The second value, or the second n, can be between 0 and 9. And the third value, or the third n, can be between 0 and 9. So all we need to do there is when we have a permutation with repetition is allowed, is we just need to multiply them together. So if we have, for example, in this situation, we have between a 0 and a 9, we have 10 different values that we could pick from our dial. So the first number that we pick could be 0 or a 9. That's 10 different values. The second dial can be between 0 and 9. Again, 10 different values. And the third dial can be between a 0 and 9. So we have the third value, we have 10 actual possibilities for the third value. So quite simply, it's just going to be in our I'm trying not to say the C word. In our example, it's 10 times 10 times 10, or 10 to the third power. So we get 1,000 permutations. Now, what we can do is we can kind of look at this too, and you're looking at it, you're like, well, each of our dials here has the same number, or the same the same range of numbers, right? Each of them can be between 0 and 9. For permutations with repetition, it doesn't always have to be that way, but this is the easiest one to actually illustrate. So kind of to repeat and to sum up here, combinations and permutations is something that can be a little bit more complicated to go through the deeper you get into it. But specifically with permutations, we got two different kinds. We got one where repetition is allowed, which we just went over, and we have another one with no repetition, and that's one we haven't covered as of yet. So when repetition is allowed, all you need to do is multiply the number of values n amount of times. So in this case, if we had a combination lock that had 4 dials on it, it would be 10 times 10 times 10 times 10. And if we had a combination lock with 5 dials on it, it would be 10 times 10 times 10 times 10 times 10, or 10 to the 5th power. Easy peasy. Now, as you can see, it can get kind of, those numbers can get kind of large, especially when we're dealing with, numbers between 0 and 9. Now, mathematically, let's talk about this just in general. Now, where does this fit in your world of math and in your study of discrete mathematics and introduction to computer science? Because a lot of this stuff that we're doing kind of has implications in what you're going to be doing coding and what you're going to be doing with with working with math when you're doing some computer science. I'm thinking, like, for example, you can have, like, for example, if you're addressing like memory locations, if you're a C programmer, you're going to have X amount of memory locations that you're going to need to address. And if you have 1,000 memory locations that could have certain values, you're going to have to come up with exactly how many permutations will be available. And I also have, like, for example, an example where, like, if you're doing cybersecurity and you need to determine exactly how many ways that a cyber attack could occur. I mean, there's ways that you can mathematically model that, and using permutations and later combinations is going to be a way to do that. So even though a lot of the study that you have with permutations and later combination, they seem kind of, albeit they seem like, academic, right? I mean, this is something that you play with academically when you're just putting together, it's like some simple math problems, and sometimes you forget, or you don't actually apply them to what you're going to be doing and how you're going to use them professionally. But permutations and combinations you use all the time. Like, for example, if you were doing cybersecurity, using permutations and combinations, you could determine how many different ways a security breach can happen, or how many different combinations of encryption keys are needed to ensure various levels of security. I mean, there's real reasons why you're going to be using permutations and combinations. So the examples that we're going to be using, and the example that I used so far, is pretty simple and straightforward. And as we get deeper into our lectures or our studies of permutations and then later combinations, they're going to get a little bit more complicated as we go. So this simple one is a good place to start because it kind of gets your brain thinking. But I don't want you to kind of fall asleep and think about, these things are all going to be easy, because they're going to get more and more complex as we go. So that's all I had for you today. Again, what we did is we went over permutations when repetition is allowed. It's a very simple formula. It's basically the number of values times the number of values, R times. So if you had 2 dials between 0 and 9, it would be 10 times 10, because 0 is a number. If you had 5, it would be 10 to the 5th power. If you had 6 dials, it would be 10 to the 6th power. Thank you for listening, and I bid you all a rest of the day. Thank you. I bid you all a very well rest of the day. Thank you.